So the truth of the matter is, I gave those first 2 talks so I could give this talk. This is where things get a little wild and wacky and fun. And now we're going from, oh yes, AI and XR, to pushing the capabilities of AI and XR and pushing the user interactions and getting into, oh crap, I didn't know that I could do that. Using AI and XR applications at runtime, dynamic script creation using Roslyn, Whisper, and ChatGPT. So Whisper I've already talked about a number of times this morning, so that is a speech-to-text engine. There are other speech-to-text engines. There's nothing particular about it other than I already had some experience using Whisper, so I kept using Whisper because it was good enough. ChatGPT, again, I have chosen that. We had the appropriate agreements in place with OpenAI that I was able to use ChatGPT. There are other AIs by Anthropic and other companies that would probably be similarly suitable to these tasks. And then Roslyn is not optional in this case. So Roslyn is a C# and Visual Basic compiler provided by Microsoft. And so that allows you to compile code at runtime. So why the heck you might want to have dynamic behavior at runtime, and then I do a demo, and then I'm going to go through how to actually do it, right? Because this is one thing. It's one thing to show this nice, like, oh yeah, I did this thing, and then you're like, well, that's great, but so what? So I want to show you, generally speaking, how to do it. So it's going to be a high-level overview, and then we're going to talk about dangers and pitfalls. And then we're going to talk about more dangers and more pitfalls because there be dangers and pitfalls. So meet your presenter. For anybody coming in late, my name is Blake Schreurs. I am a section supervisor. I am one of the co-founders of APL's XR Collaboration Center, which is a team of folks. And our job is to help ensure the success of XR and real-time 3D projects across APL. We do whatever we can to make that happen. So that's training, that's tools, that's support, that's us working on projects, helping out on research. We also propose our own research proposals and do our own projects if they get funded, if they turn out to be interesting research by the other areas of APL. I have been doing software engineering and architecture for a very long time. And I am an AR, VR, XR specialist. That is what I am best known for. But I also, there is a place in my heart for artificial intelligence, having studied that at George Mason under Dr. Sean White. So that is something that I was working on for a while at APL, and I found that applying AI to my projects was more interesting to me than designing and training the artificial intelligences themselves. So empowering users to do things with artificial intelligence is the heart of this talk. So why do we want runtime behaviors? And why do we want to add behaviors at runtime? So it allows developers and operators to extend application functionality in a seamless, intuitive manner. So basically, my goal here is I request something of the computer, and then it magically does it. Like, that is what I am going for here. So it allows you to rapidly iterate functionality. It reduces the task load on developers, and the code doesn't have to be centrally managed. Now, this is actually really interesting, especially at places like APL and other sponsor organizations. We might have a core application, right? And maybe the application is for plotting things on a globe, right? And you want to see where things are on a globe. And you have one application of that where you're tracking satellites, and you want to see where over the globe the satellites are. That's a wonderful VR visualization or AR visualization. It's a great use of the technology. And you might have another one where you're doing that for submarines, and you're showing where your submarines are on the globe. One of these is way more sensitive than the other. Your data constraints, right? You're going to be talking about different levels of data classification for the submarines than you are for the satellites. So you don't want all of your satellite-related code and your submarine-related code to commingle if you don't have to. So this allows you, right? So essentially, we're using a plugin system to create a data plugin for your satellites and a data plugin for your submarines so that those pieces of code can exist in their own environments, in their own worlds, and that you don't have to have a single monolithic application that could do either, right? because there's sometimes security and maintenance considerations that would come with something like that, right? So this allows us to, by having a plugin infrastructure, it allows each installation to only have the functionality that it needs, and then we're also able to extend that functionality as people use the system. So here is my demo.
So for this demo, I've taken the headset off just to provide a more stable recording because we're going to be going in depth here a little bit. So we have some objects in the scene, and maybe we want to make some changes to them. Normally, that takes a developer who is familiar with game engines or programming to be able to make changes to a scene. But we want to enable just everyday people to be able to do that so that they can have worlds that they can manipulate and create and do with as they please. So in this case, we're using speech to text to be able to get a prompt, and then we send that off to an LLM to get a code back, which we then dynamically compile at runtime and inject it into the scene. So if I want to make a change, I simply just record and talk like this. Find the capsule and turn it green. So the first thing we're going to see is the speech to text just pops up. It does a great job. It goes out, requests code. We're going to see that it comes back with code. It's going to compile it, and then the capsule will turn green, just like that. And again, I'm going to do it a little bit differently this time. Find the cube and turn it 10 degrees per second around the y-axis. Now, I happen to know that the y-axis is the direction that I want it to turn, but you could have also just said around the up-axis and it would have picked it up just fine. I also very intentionally used similar phraseology for both of those commands. I had it turn the capsule green, and then I had it turn the cube. And the LLMs, the generative AI, is smart enough to know in context that those are different behaviors, which is really different than traditional programming, where if you had keywords like that and you reuse them, you'd most likely get a bug. So these tools are providing wonderful new ways that we can empower end users without having them to be technical experts on every part of the technology that we're using.
So I'll also say, in this situation, right, this system has gone and it has written those scripts, and those are scripts that exist in my project now, and that the next time that I start it up, I can run those scripts again, right, that they are authored. And it took me less time to do that than it would have for me to even open up Visual Studio to write that turn script myself, right? So how the heck did I pull that off? So the first thing you need is a runtime compiler, right? You need to be able to take the code and you need to be able to compile it. So in this case, we're using Roslyn, which is open source .NET, and it's available for C# and Visual Basics. And thankfully, Unity is in C#, so that makes that easy. In theory, you can pull all the DLLs yourself, like Microsoft makes them available, and you should be able to bring them into your Unity project and configure it so that you can make calls to Roslyn all yourself. I tried that. Don't do that. Really. There's an asset on the Unity Asset Store, in this case, that met our security requirements. It was $20, that they've essentially done that for you, right? Because it's open source. They said, like, yes, here's the package. We have Unity-ified Roslyn for you. Here you go, and just use that. You know, even if you have to spend time doing like a security audit or something like that on a package that you download, that is going to be way easier than pulling the DLLs yourself. Speech to text. So again, we're using Whisper. I used Whisper just because I had used it in the past. The code was available. Any quality speech to text system will work. This is the primary interface, though, right? So we're talking about you're going to want a really good speech to text system because a lot of them come up with some very interesting errors. And so you're going to go for the best speech to text system that your project can possibly support. Otherwise, people are just going to get frustrated because it will create code to do things that you did not want it to do. So having good speech to text is pretty important. So a high quality online model is really recommended. So an LLM, again, leading edge LLM that you can reliably generate code. So that's going to be, again, usually a model that you're spending money for on a cloud. You know, you're going to need to find a vendor where you can get some really high-end stuff. In this case, I was using ChatGPT 3.5, so things have only gotten better with 4.0. So the delays in that demo have actually gotten much shorter with the newer variants of ChatGPT. I will say we have tried it with local LLMs, so there's like GPT for all and other type things that you can use on premise, and they are not good enough. They are not even close to good enough. They're probably 3 to 5 years behind where the real high-end online models are. They will generate things that to us just look like gobbledygook. They don't even really look like code or pseudocode. It will not compile. It is not convincing. And they are getting better, and so maybe it's less than 3 years out, but I have had absolutely zero luck with any of the local LLMs for this demanding a task, because writing code is a very demanding task. Lastly, the thing that you're going to need, I really strongly, highly recommend, like I guess you don't technically have to have, but really you should, is a plugin API of your own design, right? If you're going to be extending software and say, I want this to be able to do new things, you need to be able to scope what kind of new things that it is able to do. And we're going to talk about that more in a little bit. So designing the system, so this is the overall architecture of my various things. So we have a speech to text and we have an input classifier. So I want to be able to do other things like select objects, right? Maybe I want to be able to select the sphere and the cube so that I could delete them, because again, my user interface, I don't have, in VR, I don't have a full keyboard available. I want to be able to keep it very simple, especially as we do away with controllers, as we see more and more systems use hand tracking. That reduces the variety of buttons that I have. So that means that I need my speech to text to be able to be really good. So I need to classify what kind of behaviors I want. So in this case, I'm saying I want to write a script. So we prompt the LLM for a script. We go out to our whatever. There's some script engineering. I will show you that as well. And it will say, hey, ChatGPT, write me this script. You download the script. You do some safety checks. And then you compile it. And then you unload the existing script if there is one, and then you load and run the new script. So, dangers and pitfalls. It is, by all means, the most security nightmare thing I have probably ever created in my career. It is because it is not inherently, it's not like I'm putting SQL injections thing where it says, here, hack this. But it is so open. It is so new to be able to do this kind of thing at runtime interactively that we do not fully understand the security implications of this. I have some basic security stuff in place. We'll talk about that in a second. But the truth of the matter is, the entire security realm is about doing things you're not supposed to be able to do, right? Like, the original Xbox was hacked by a malicious font file, right? Like, if a font file can screw you up, right, I have no idea what a malicious actor with this kind of access to the system will be able to do. We can put some checks in place. The first one is thankfully the library that we're using for Roslyn allows you to say, reject it if it uses a certain library. So if it has a file access system.io, right, is your file system access, I disable that. So if that system.io shows up in the code, it won't compile. Same with direct web access, right, and reflection, right, because an easy way to get around that would be to use reflection. So I turn off reflection, direct web access, direct file access. Those are the things that I turned off like immediately. Is that going to be enough? No, probably not. Right? So there is, so all of this is, there is new capability here, and with great new capability also comes a great new attack surface. And I have seen it create code and do things I didn't think it could. Like, I have legit, like, I told it to create me a new cube once, and it created a cube out of the blue. I didn't even know that it could do that. Like, so it gets wild. It'll also write code that will compile and doesn't do what the user intended it to do. Now, as a programmer, I will tell you, I have implemented things that people have told me to do which weren't what they actually intended for me to have them do. That is a requirements problem. It is a communication problem. That is understanding the problem to come up with a better solution. So is that really an LLM thing? And the answer is yes, maybe kind of. But also, are there things that we can do to help mitigate some of these things? Can we adjust the prompts to make it so that we'll get more what we actually want instead of what we asked for? In terms of doing things that I didn't really want it to do, I love showing off my bugs. So in this case, I asked the system to rotate everything along the z-axis 10 degrees. And so it rotated like everything. So what's funny is that one cube seems stable, and it's only because the camera and the cube are rotating together. So, and then actually the world is marked static, so the world doesn't rotate. But the camera is rotating, my user interface is rotating, everything is rotating, right? So this is one where I did not properly scope what the system had access to, and so I got crazier results. So, more dangers, more pitfalls. It found more bugs in my API than I found in its plugins. We are at the point where I will say a lot of LLMs are generating mediocre code. Now, if you tell it from 0 and you ask it for code, it is going to come up with code that's okay. However, one of the things that I'm finding is with that API, when I provide that API to the LLM and says, here is the baseline API that I want you to use, the code that I get back out is almost always respectable. And so I'm going to show an example of that. So I will also say it could expose or accidentally exploit bugs in systems. So if you have a bug in your code, like maybe you are accessing, are too permissive in providing access to the user interface, it will go ahead and it will start rotating the user interface and manipulating that because it has access to it. The other thing that I noticed, I have an ability to call out to a website. I say, hey, go out to a website and notify the user whether or not the website is up or down. And I had it do that every second. And it was using text-to-speech to actually tell me. And that got really irritating really quickly. Also, I didn't have a way to turn that script off at that point in time, so I had to stop the program and then delete the script. Because it would just run it on startup. You don't want to run these things on startup necessarily. You want to give your user the option to run it on startup. You want to give the operators the ability to have control over these. And so that's not something that we're used to implementing. But that's actually what those checkboxes were in the previous video, was my, turn on the script, turn off the script. Non-determinism. So again, we're talking about a stochastic system. And so when you start putting AI next to AI next to AI, you start getting some imprecision, right? It is not a fully deterministic system, and that you start multiplying those errors. And so that gets worse and worse and worse and worse. And so I find by having a deterministic baseline, that means that that gets rid of a lot of the hallucination-y wobbliness, weird AI-type behaviors, so that we're not multiplying AI strangeness against AI strangeness, that we're going to a deterministic, well-defined specification that takes that and goes to 0, and that where it either compiles or it doesn't. It either meets the interface spec or it doesn't. It either compiles or it doesn't. And so by sandwiching it, so this is my hamburger, right? So I got my two deterministic buns, and then I got my stochastic meat in between. And by doing that, I am able to greatly limit the amount of AI weirdness that I am getting out of these systems. Access is a problem, by the way. For programmers, systems are unbelievably permissive. And so if you have a programmer access to your system, you can do a heck of a lot. And this is essentially providing programmer access to your system. So use your API to constrain what the AI code has access to. What does that look like? So in the big circle, right, that's everything that you have access to. You have access to the file system and the entirety of the World Wide Web and who knows what else, right? And that you can just write a program that goes and tries to download the internet. and you have full carte blanche, very little filtering access. And so you don't want to give your LLMs access to that. You don't want their scripts to write to that. Really, you have a limited set, right? Maybe you want it to be able to access files related to your project so that you are scoping and protecting. This is the AI equivalent of sanitizing your inputs, right? This is making sure that the data that it tries to access stays within a range that you expect. Again, there is an entire field of cybersecurity that is the job of trying to break out of that. So again, there are no promises here, but we should at least be making, we need to recognize that this is a problem and be making attempts into understanding that we need to limit the access. And so we have this specific set of things that we should have access to, and that we have a data proxy interface as part of our API. And so that your LLM codes to that and uses that instead of trying to use the direct file access. And you should see some of that for the web. So an LLM prompt, this is like how I do it, right? This is what I tell ChatGPT. You're a Unity C# programmer creating plugin agents. Any class you might write must inherit from plugin agent. You only write code, no explanatory text. Comments are fine. Use the C# code tag, not the C# code tag. Turns out it was, it would sometimes use one marker or another marker for its output, and so I couldn't parse it. And so I have to force it, like use this marker. These are the things that I had to do to be able to actually parse the output and get the code. The next thing I do is I try to avoid collision with other classes. So I tell it, like, these things exist, don't reuse these names, right? So that I'm not stomping on other scripts that I've already written. And then your plugin agent is as follows, right? And then this is where you put your code. And my code looks this is a good hunk of it, where, I am, essentially, these are really empty, but it just says, this is what you can use, right? This is what you can access. And so you'll see, so I have request website and stop reading website, right? And then what is the user looking at? And then I have some of the Unity hooks that I've passed through so that, if I want it to do some Unity specific stuff, it can. But so when I have it request website, it calls a plugin data handler request website. So it is not using web requests to request the website directly. It is going through that interface, right? So it must use, the plugin has to use request website, which goes through a filter so that I have much more control over what it does or does not try to access. Right now, those filters don't do much, but the fact that they're there is kind of the point. Now, so in this case, I said, go to google.com every 10 seconds and tell me whether or not the website is up or down. And just write that script. And it did. Like, this is the code from the script, no edits by me at all. So it's using a website status checker. It is a plugin agent. It goes to google.com. That is a constant up there. That is a completely valid way to do it. What is the plugin name? It is the website status checker. It was able to come up with that. And then again, my code uses that name and provides that to the user of, this is the website status script or website status checker script. Do you want to run this script? Right? So I'm using that for the user interface. On enable and on disable. So, we mentioned it's using Unity, but I don't have start and update. No, I don't have start and awake available because I know the application should already be running. So I want to enable and disable the scripts on that. So when I enable or when I disable, it is able to use this. This website read token, this is a convention that's used when you have a service subsystem, right? You're just given an ID of like, I want this website to be checked for me. Right? And here's an idea of that request. I didn't tell it to use that. I provided that in the interface. So when I showed it my API, I provided it that, but it didn't actually, I didn't have to tell it to use read tokens. It knew to use read tokens. And then when I disable it, it stops reading the website and provides the read token. And then when the website is read, it notifies the user whether or not it's up or down. So this is completely reasonable, viable code. The only thing that I would say is a little concerning to me is it does know that it's a Unity C# programmer. So at the top, it says using Unity engine, which again is very permissive. So you can do a lot with the Unity engine namespace. The other thing also is I said, make sure it inherits from plugin agent again. I have seen cases where it forgot that, so I did reinforce that instruction twice. So that's it. That is how you would create a system that is able to dynamically do things on the fly, touch of a button as people are doing stuff. So we have 4 minutes. I'm happy to entertain any questions. Yes?
So back in your demo where you had the three objects, there was a capsule, cube, and I guess I would call it a box.
Mhm.
Yes. Okay. So the question I have is I'm not familiar whether or not capsule is a primitive in Unity or not. How did it associate capsule with that object? Was it the LLM smart enough to like be aware of what was in there and then figure it out, or is there a tag that's on that object and it said, "Oh, that's the capsule. I know what it is."
So great question. Two-part answer. So in the demo that I showed you, game objects have a name, right, when you create them. And the default name was capsule, right? So my capsule is appropriately named capsule. And so the LLM did a find object by name and just searched for, give me any objects named capsule. And so if I had labeled the cube capsule, if I had named the cube capsule, as one could do, it would probably color the wrong thing. But again, is that really its fault? Because now I'm naming things stupid things, right? The other thing that I have started to do with the object selection code is that when I want it to pick things, and part of my API is to get a list of what's in the scene. Again, because I want to limit it. I don't want it to show up the user interface and other things. And so that for the objects that are dynamic in the scene, I'm keeping track of certain attributes. And so that I can say, when it is looking for objects, I can say, here are the attributes that I have. Here's the material, here's the color, here's the name, here's the original shape, here's the position, right? And then provide that in a JSON list to the LLM so that it can go through and it also has an ID, so it can go through and say, okay, I want to change items with ID 3, 7, and 28. All right. What is reflection? So reflection is the runtime ability to make runtime calls from within the code. So it is without using a compiler, a way to interpret text as code and be able to modify your own system. So you are looking at yourself and able to see the parts and be able to manipulate them. It is very powerful, but it is also fraught with many, many security hazards.
Is that why you didn't make it in file time code, not like a JavaScript type script code?
Is that why I had it do?
Well, I was kind of curious why you're kind of forcing your users to have Unity installed on your system to compile your scripts instead of having it generate script language that just
So in this case, Unity is just the platform that I am using, and so that is what is easy for the compiler to compile to, and then I can just bring it in and use it. That they don't have to have like the Unity editor installed on their machine. I'm running these demos from the Unity editor, but I can have a built binary that I can give somebody that is not running in the Unity editor. So they don't have to have Unity installed. The scripts that it creates are going to be Unity scripts because that's what will get dynamically compiled and executed and brought into the executable. But all of that actually can happen without the Unity editor on the machine. And I chose that just because I knew it was fully featured. Yes? Not that I have seen, but I also haven't tested that robustly. So the question is, if I asked it to do something that might require other libraries, would it be able to do that? Not that I have seen. Right now I'm having it generate scripts. I have not tested to see if it would generate scripts that would try to install other libraries. That is a good question. Yes? Okay, so the question was, have I thought about using this approach to using AI for other types of analysis, specifically doing, I'm sorry, what kind of analysis? Oh, Monte Carlo simulations. Right. Oh, for scenario planning and whatnot. So I think this is actually a good general thing to keep in mind. This is, this is not a super scientific thing. This is an engineer's approach to making this stuff go. So yes, I think this would be applicable. Having a baseline, having worked on systems that have tied AI questions and then AI answers, and then you have multiple layers of it over and over again. That's where I think I see a lot of these systems get into trouble. So having a baseline where you are essentially organizing and classifying your responses into something that the next AI, you have a high confidence that the next AI would be able to understand, I think is really valuable, right? So if I am saying, I'm coming up with a novel threat scenario, instead of just having it author the novel threat scenario and then provide that to the next AI on what might be the possible outcomes of this threat scenario, I would probably have a layer in the middle there where I'm trying to organize and qualify it so that it's better prepared for the next. Yeah, sorry.
I know we're over time, but I just want to bring up one thing real quick. I know I've seen your demo before where it rotated everything. I picked up on something this time where it's not just a behavioral bug, it's actually a potential opportunity for exploit.
Yes.
It is exposing the transform hierarchy of your UI.
Yes.
Because the deeper it's applying not just a 10-degree rotation to everything, but a 10-degree rotation at each level of the hierarchy. So the text was spinning faster than the box that contained it.
Yes.
So if there's something to be exploited in that hierarchy, guess what? You just exposed it.
Right. So this is part of the reason why I started talking about that, right? Because this is like, oh, wait, it has access to everything, and we probably don't want that. All right, so we're at time. Thank you all. I will be around for questions later. You'll find me, I'm sure.